Welcome to this tutorial on cloud encryption, where we'll explore how to protect your data in cloud environments. Encryption is one of the most critical security controls for safeguarding sensitive information, whether it's stored in the cloud or moving across networks. By the end of this video, you'll understand the key strategies for implementing encryption effectively in your cloud infrastructure. Cloud encryption can be divided into two fundamental categories. First, we have data at rest encryption, which protects information when it's stored in databases, storage buckets, and backup systems. Second, there's data in transit encryption, which secures data as it moves between different services, users, and networks. Both types are essential for comprehensive cloud security, and most organizations need to implement both to ensure complete data protection. Let's dive deeper into encryption at rest. There are three main approaches to protecting stored data. Server-side encryption means your cloud provider automatically encrypts data before storing it on their infrastructure. Client-side encryption involves encrypting data on your end before it even reaches the cloud storage. Finally, disk encryption provides full volume encryption for virtual machines and databases, ensuring that entire storage volumes are protected. Each method has its use cases, and you can often combine them for enhanced security. Here's a practical example of implementing server-side encryption in Amazon Web Services S3. Using the BYOK Python library, we first import the library and create an S3 client. Then, when uploading an object using the put_object method, we specify the bucket name, the key or file name, the data body. And critically, we set the server-side encryption parameter to a ES256. This ensures that Amazon automatically encrypts your file using the advanced encryption standard with a 256-bit key before storing it. Managing encryption keys is just as important as encryption itself. Cloud-managed keys mean the provider handles everything: key generation, rotation, and storage, which is convenient but offers less control. Customer-managed keys give you full control over the key lifecycle using services like Amazon Web Services Key Management Service or Azure Key Vault. Bring Your Own Key, or BYOK, allows you to use your own keys to meet strict compliance and regulatory requirements. Finally, hardware security modules, or HSM, provide the highest security standards by storing keys in dedicated hardware devices that are tamper-resistant. Now let's look at protecting data as it moves across networks. Transport layer security and secure sockets layer protocols are the foundation for encrypting data flowing between clients and cloud services. Virtual private network tunnels create secure encrypted connections between your on-premises infrastructure and cloud networks. Finally, API gateway encryption ensures that all API communications are protected by enforcing HTTPS for every request and response. These mechanisms work together to prevent attackers from intercepting sensitive data during transmission. Here's how to enforce HTTPS-only traffic in Microsoft Azure. Using the Azure command line interface, we run the storage account update command, specifying the storage account name, resource group, and set the HTTPS-only parameter to true. This ensures that all requests to your storage account must use encrypted HTTPS connections. You can verify this setting by running the storage account show command and querying the enable HTTPS traffic only property. This is a critical security hardening step that prevents unencrypted access to your cloud storage. Let's examine the common encryption algorithms used in cloud environments. A ES256, or Advanced Encryption Standard with a 256-bit key, is the industry-standard symmetric encryption algorithm used by virtually all major cloud providers. RSA is an asymmetric encryption algorithm primarily used for secure key exchange and creating digital signatures. TLS 1.3 is the modern protocol for securing data in transit, offering improved performance and security over older versions. Finally, CHA-CHA-20 is a fast stream cipher that serves as an alternative to a ES, especially optimized for mobile devices and Internet of Things applications where hardware acceleration might not be available. Let's cover some essential best practices for encryption implementation. First, enable automatic key rotation by scheduling regular rotation of your encryption keys to minimize the risk if a key becomes compromised. Second, implement comprehensive audit logging to monitor all encryption key access and usage patterns, helping you detect suspicious activity. Third, adopt a defense-in-depth strategy by layering both encryption at rest and encryption in transit throughout your infrastructure. This multi-layered approach ensures that even if one security control fails, others remain in place to protect your data. Let's recap the key takeaways from this tutorial. Always encrypt data both at rest and in transit to ensure comprehensive protection. Use managed key services provided by your cloud platform to simplify key management while maintaining security. Implement a defense-in-depth strategy by combining multiple encryption layers and security controls. Finally, continuously monitor and audit your encryption implementations to detect issues early and maintain compliance. By following these principles, you'll build a robust encryption strategy that protects your cloud data effectively. Thank you for watching and stay secure.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.